Simulation gives you a lot of flexibility, and so you can deal with these challenges very well. So I think you all want to use simulators at this point. Okay? In reality, if you look at the level of realism that you get, it turns out to be a little bit different. So the answer is to, first of all, build better simulators, and there's some really good groups working on that. The other one is that it would be nice to have a test bed that allows me to overcome these challenges. And that's where this project comes in. The idea is very simple. 30 seconds. We have real wireless devices that transmit signals. But instead of having them travel through free space, we capture the signal and digitize it. And then we digitally emulate signal propagation through the ether. So what I effectively have is a programmable ether. And this happens in real time, so the devices just happily do whatever they always do. It turns out that it gives us not only a real test bed, but it gives us all the good properties that we like from the previous slide. So moving on to broader impact, kind of three areas that I want to highlight. The most visible one is actually the fact that we've built a test bed like that, and we've had this online, accessible over the internet for external groups since 2007. So it's been used by researchers, there's papers that have been published with results like this, and there's used in courses and so on. The way I really look at this, one of the advantages here is that this significantly lowers the bar for running wireless networking experiments. Putting together a test bed, maintaining it, and so on is actually tough. It's hard work, and so this makes it easier. What I want to point out is that this effort is not unique. There's this whole GE effort which is building test beds. This is in some sense maybe a not so representative or maybe representative example. The second thing I want to highlight is that this is an example of a big systems research project. This involves all kinds of stuff, going all the way from signal propagation, which is really the WE area, all the way to programming, system-based stuff, distributed computing to manage the test, etc. And so this is an exceptional learning experience for students. This is, you really can train people in a very unique environment that I think is going to pay off for them throughout their career. And so I think this is an important thing to emphasize. The third thing I want to say in terms of broader impact, my hope is that this type of test bed will in fact allow us to do a more scientific evaluation of wireless networking, because a lot of the evaluation right now is just not and so, in the breakout we can discuss these further. A couple of the challenges that I face in this type of project. One of the issues actually all three of them kind of, or at least two get back to some issues that Jeanette Green raised in the first talk. First one is that making a system like that available to users involves a lot of work that is not research. Right? And so there's kind of this tension now. If I have a student, how much time will they spend on kind of helping making the broader impact happen versus doing research? The fact of the matter is that once they go and interview, the research is what matters. Okay? I think students get very little credit for doing broader impact activities. And so I think this is a real issue. Okay? This is a real tension. And there are many cases where I have to make a call between what's good for the student and what's good for the project. Okay? And these are tough calls to make. The second thing I want to mention is that student turnover makes it very hard to run in a university environment. They insist on graduating. Oops, there goes my expertise, right? The final thing I want to mention is that and again, this gets back to the point that Jeanette makes, there's actually a different way of evaluating broader impact from intellectual merit. So this is a graph that I came up with. So we have an x-axis and a y-axis. X-axis is the number of people in the project, size of the project, okay? So this is how a lot of people envision research impact being measured. You add more people to the project, more research, more papers, more citations, more graduated students, and life's good, right? Broader impact doesn't work that way. Broader impact works kind of like this, right? So if you don't have a system, you don't have broader impact, right? If you don't have a system, you don't support users. So you really kind of need to invest to get that system going, and then you can support users. And then you also have the impact of having multidisciplinary kind of people interacting with each other. And that's when the real payoff happens, right? And so the issue here is that the project structure is different, and also how you evaluate broader impact is different. Okay? Thank you.